Hi everyone, my name is Rogelio. I'm part of the Jest core team, and I work at Docker as a front-end engineer. So today we're going to be talking about Jest as a platform. But what does that mean? Let's break that statement apart. First of all, what is Jest? Jest is a JavaScript testing solution that focuses on being easy to set up, providing instant feedback, and making sure that it works out of the box. And what do we mean by platform? By that we mean something that is extensible, that works with our existing tooling, and that allows us to build on top of. So to better understand what Jest as a platform is, let's first look at what Jest is strongest at, which is testing. So we always go and try to write some tests. But then halfway through that, we realize that we simply end up not writing them. And that's because there's a lot of tools that we need to stitch together. And as the effort of writing tests become higher, we write less of them. And the same is true for the opposite. So this is the exact problem that Jest tries to solve. It tries to make sure that you only have to think about a single dependency when you're writing your tests, which in this case is Jest. So let's go ahead and set up Jest just to see how that works. And by the way, for the rest of the talk, we're going to be using this small application. It's called Emoji Cinema. Basically, it takes the name of a movie and it returns the emoji representation of it. For example, if you type Frozen, you'll get a snowflake and a dress. If you type Finding Nemo, you'll get a lens and a fish. And if we see how this application works, at the core of it, it has this search movies function, which basically takes in a query and returns some movies. For example, if you pass the letter F, it will return you all the movies that match the letter F. Let's take a look at how this is implemented. It takes in a query, and then it has this emoji map. We're going to filter through it and only returns the movies that match that given query. And our emoji map looks something like this. Basically has the title and the emoji representation for each of the movies. And here is how our project structure looks like. So let's go ahead and add Jest to it. So here we have our package.json, and we're simply going to go ahead and add Jest as a dependency, and then we're good to go. So now that we have done that, let's go ahead and start Jest in watch mode, and let's see what happens. So you can see that it found that there's no test files. So let's go ahead and write a test file for this search movies function, searchmovies.test.js. And as I save it, it reruns the test and tells that we don't have any. So let's write a test for it. It returns the movies that match that given query. And it expects search movies of F to equal some set of movies. You can see as we start saving it or making changes to the expectation, Jest will rerun it and give us a pretty printed error. So Jest has a lot more to offer. But in the interest of time, and because we want to start talking about Jest as a platform, that's as far as we're going to get. So if you're interested in learning more, feel free to go to the Jest website. But we did get really good things with Jest. So what were those things? We got an immersive watch mode experience. We got tests that run really fast. We got great user experience. We got a deep Git integration, and all of this with zero initial configuration. So now that we all know about Jest, let's start talking about the platform aspect of it. And for this, we're going to be looking at it from a couple of different perspectives. The first one is to be able to cherry pick specific features of Jest and use them as standalone packages. The second one, which we'll talk more about later, is to be able to put your tooling on top of Jest. And this allows us to leverage Jest features and its infrastructure. And the third one is a couple of things that are coming down the pipeline, specifically plugins. We'll talk about them at the end. So let's start by cherry-picking features of Jest. Up until now, we've been looking at Jest as this standalone package. But if we zoom into it, we'll realize that it's composed by several independent packages, each of them allowing us to extend Jest and use a small piece of it in a different way. For example, remember when our test failed and Jest gave us a pretty printed diff? Well, this was powered by the Jest diff package. This is great because it gives us all of Jest diffing algorithm as a standalone package. And it allows us to diff deeply nested objects or any other serializable value. Another package that I really like is Jest validate. This is great for anything that has a configuration in it. And in fact, it is what Jest uses for validating its command line arguments. So we simply need to give Jest validate a config, and then provide it with an example config, and it will figure out the rest. For example, if we change our config to an invalid value, then Jest validate would give us the appropriate error. And it's robust enough that it will even give us links to our documentation, for example, or allow us to deprecate some options. In this case, we're deprecating watch in favor of super watch. So that's how we cherry pick features of Jest. Now let's take a look at putting our tool on top of Jest. And this is really cool because it allows us to get all these features that Jest has in our tool. And to better understand what this means, let's take a look at the life cycle of a test run. It happens in 3 different parts. First of all, Jest finds your test files. Then Jest runs your tests. And in the end, Jest reports the results. And as you can see, a lot of the heavy lifting is done when Jest is either finding the test files or reporting the results. So imagine if we could swap that middle part, also known as the runner, with our own tool. This means that Jest would do all the fancy work for us. So we've been talking about Jest platform, and we introduced this concept of runners. But how does this look in practice? I'm sure that a lot of you at this point are thinking, like, sure, Jest is nice, but at work we have this Mocha code base, and even if we wanted to migrate it to Jest, we don't have the time or resources to do that. Well, imagine if we could keep Mocha as our testing framework and use Jest for the rest. This means that we could leverage a lot of Jest features without changing almost any lines of code. Let's take a look at how this works in code. So here we have our same emoji cinema project, but it's, in this case, using Mocha instead of Jest. So let's go ahead and add Jest on our Mocha runner, and then we're going to tell Jest to use that given runner. And here we have, again, the same project, and in this case, it's using the assert library to make it work with Mocha. But if we go ahead and start Mocha, we can see that it would just run the test as expected because it's a Mocha project. But if we then go ahead and start Jest in watch mode, we'll see that it will find a test, run the Mocha test, and then report back the results. And as we make changes to that expectation, it will give us the appropriate error while still powering the test with Mocha. And because it's using Jest infrastructure, we even get stuff like code coverage out of the box. So we just saw how we can completely swap the test framework and still leverage Jest features. And the cool thing here is that we can swap it for way more than that. And for this, we're going to need to start thinking about Jest less as a testing platform and more as a tooling platform. And ESLint is a great example of a tool that we all use. But it could leverage some of Jest watch mode and parallelization. In fact, Airbnb started using this a couple of months ago. So how do we use this ESLint runner? We're going to do the same thing that we did for a Mocha runner. We're simply going to add it to our dependencies, and then we're going to tell Jest to use that runner. We're also going to give it a nice display name so that we have an identifier when we run our tests. And because it's ESLint, we're going to tell it to look at all the JavaScript files. OK. So now that we have it set up, let's go ahead again and start Jest in watch mode. We can see that it found our files, and it reported the corresponding ESLint errors. And as we start fixing each of them, only the remaining errors will show up. And again, because it's leveraging Jest features, we can even use the filtering mechanism that Jest has to only look at a single file and run ESLint on it. And as I make changes to it, Jest watch mode would just pick it up and run ESLint. So if we can use this for Mocha and ESLint, it probably means that we can use it for way more than that. For example, we can use it to run Python tests. Here's Jest running Python tests. Over the last couple of months, several runners have emerged, and each of them at our different stages of their development. But I'm really excited about what the community is doing with Jest runners. So we have been talking a lot about runners. It seems about time that we start writing our own runner. In this case, it's going to be a Blade runner. So imagine that we have this company policy, that every file needs to have these two emojis. And if it doesn't have them, then it will fail. And if it has the two emojis, then it will pass. So how would we implement such a thing? To understand this, let's look again at the lifecycle of a runner. At the lifecycle of a test run, and specifically at the runner part. First of all, Jest hands in a list of files. And then the runner, in this case, Blade runner, will spin up independent node processes where on each of them is going to run the test. In this case, the test is going to be simply to check for the presence of the emoji. And then after that happens, it's going to report the results, either pass or fail, and Jest is going to take over again. And for the most part, this happens in two different parts. The first one is the entry file. This is what Jest is going to be talking to. And the second one, it is our worker file, which is going to get spinned up independently in its own node process for each test file. And as you can imagine, there's a lot of logic that is happening in between these two parts. For example, handling test interruption, or keeping Jest up to date with the status of each test file, spinning up the workers and cleaning them up at the end, and also reporting the test results back to Jest. So to encapsulate all of this logic, I created create Jest runner, which basically you simply provide a path to your worker file or your run file, and create Jest runner will take care of all the parallelization and orchestrating all the processes behind the scenes. So now that we know about this, let's go ahead and actually implement our runner. We'll start with the entry file. Remember, this is what Jest is going to be talking to. And it's going to be really simple. We are going to simply require create Jest runner, and we're going to provide it with a path to our worker file. In this case, it's going to be a run.js. And now let's go ahead and implement our run file. This is simply a function that, among other things, is going to get the test path. Because remember, this is going to get instantiated once per test file. And on it, we're simply going to read the contents of the file. We're going to check if it includes those two emojis. And based on that, we're going to either pass or fail. And by the way, create Jest runner also has these like pass and fail functions that they're simply going to normalize the data to the format that Jest is expecting. So now that we have that, let's go ahead and give it a try. We'll start by starting Jest in watch mode. Let's see what happens. And we're going to only look at the search movies files. We can see that it reported the corresponding error for both of them. And as I start making changes on each of them, they start to pass, and only the remaining files keep failing. So that was Blade Runner. And at this point, you might be thinking, like, sure, we've talked about these 3 different runners. They all seem like independent projects. But for all of them, we have been modifying the same package.json, which is really hard for like having it in the same project at the same time. For this, Jest allows us to move configuration into specific config files. For example, for Mocha, we're going to move it to a jestmocha.config.js. For ESLint, we're going to move it to a justeslint.config.js. And for Blade Runner, we're going to move it to a justblade.config.js. And now that we have them in separate files, Jest allows us to load them as independent projects. And the cool thing here is that we can load them all concurrently using one single instance of Jest. Let's see how that looks. we're going to go ahead and start Jest in watch mode again. But this time, we're going to tell it to load the projects that start with jest-something.config.js. And you can see that it found the 3 projects. And as I start making changes to the files, only the corresponding runner fails, and the rest are passing. So those were the runners. And at the beginning, I mentioned that there's also a couple of extra things that makes Jest as a platform even better. In this case, are plugins. So these are a couple of things that we have going down the pipe that are not ready yet, but they're coming soon, like fairly soon. So we started looking first at cherry picking, and then we looked at putting our tool on top of Jest, and now we want to look at this plugin part. So why do we need it? Like, what does it give us? It gives us a couple of cool things. It allows us to hook into specific parts of Jest. And they play great with runners. It allows us to implement our own autocompletes, for example, in our watch mode. It allows us to have some interactivity with the user, which we're not able to do with runners. And we're going to start looking at these plugins from 2 different perspectives. The first one is this Jest hooks idea. And the second one is the interactivity part. For the Jest hooks, let's look again at the lifecycle of a test run. And we can imagine that there are small extension points in that lifecycle where Jest will allow us to hook into and extend the functionality. And this is really cool because we can, rather than just bringing its features and infrastructure to our tool, we can give features to Jest with all the tools that we build. For example, it will allow us to hook into different parts. And a plugin looks like this. It's simply an instantiatable object that has an apply method and receives this Jest hooks object. And this Jest hooks object has methods like should run test suite, for example. And this is great for deciding which test suites we should run. Has another one that is test run complete that would get called every time the test run is complete. And this is great because we can get the results and take action based on them. For example, if we're in watch mode, we could say, oh, actually, in the next test run, we want to skip the slow test because in the results we have all that performance metrics. Or we could say we want to skip the snapshot that failed or whatever makes sense for your specific plugin. It has other hooks like getting updates whenever a file changes. In this case, it will give you the list of all the test paths that Jest is watching across all the runners. And this is great because you can use it for like creating your own autocomplete based on your own heuristics. And there's a lot more Jest hooks to come. This is just the beginning of plugins. But the other part is the interactivity. Because all these extension points just allow us to make decisions and allow us to bring features to Jest, but they do not give us a delightful experience that interacts with the user. And this is where the interactivity part comes in. It allows you to get keyword input or even just get full control of the Jest experience at that point. So how does this work? Right now, what's the part where Jest includes most of the interactivity? This is this watch menu, right? That's where you type something, and based on that, Jest takes some actions. So imagine if we could add our own behavior there. We can do like press S to do something. And basically, in your plugin, you simply provide the key that you want to be listening to and some prompt related to it. And when the user does press that given letter, then you will get called in this run where you can just show your prompt or whatever is relevant in your plugin. And this is great because you could do a plugin that, for example, is skip flaky tests if you had a test server that is taking care of all those metrics, right? Or you can add a plugin at some point that has really complex filters. And you can say, only run the tests that start with this specific value or please exclude these other tests or really fancy stuff. Or you can get to other stuff like, oh, I want to auto-fix the test that failed by doing some fancy stuff. But too much about that. Let's go ahead and start talking about Jest plugins by writing our own plugin. In this case, we're going to write a plugin that allows us to filter by file tags. How does this look? Imagine that in every file, we could add a tag, for example, for smoke tests, or for our admin test, or accessibility. And by adding this plugin, Jest will allow us to just run those given tests. So let's go ahead and write it. The first thing that we're going to do is we're going to say that we want to be hooking into the letter S, and that our prompt is going to say filter by file tags. And then at some point, Jest is going to call us. We're going to show our prompt. I'm simplifying, obviously, what the show prompt does, but you get the idea. And basically, we're going to save it in a tag variable. And then we're going to hook into that Jest hook, which is the should run test suite. And we're simply going to say, hey, check if this test path has this tag. Also, the hashtag is a function that I didn't include, but it basically goes through the file and through the doc block and checks if it has that tag. So how do we use it? We use it in a pretty similar way that we use it with runners. We simply tell Jest to use that given plugin, and we're good to go. So let's give it a try. We'll start Jest in watch mode, and I added a couple of more tests. But you see that we now have this extra line in our watch mode that says filter by file tags. Let's press S and start typing that we want to run all of our smoke tests. We don't have any, so it didn't run anything. But as we add that tag to our test file, Jest will pick it up and rerun the tests. And we can make changes to it. For example, run the admin test. And as we start adding those tags, Jest will start running those tests. And the cool thing here is that we're actually using Jest to run 3 different runners that are doing 3 completely different things in watch mode with a plugin that is filtering those files in a way that was not possible before. So that's what I'm really excited about. And that was our file tag plugin. You might be asking, sure, when are we going to get this? Hopefully fairly soon. Jest is actually already using these plugins internally. In the latest version of Jest, all of these lines in watch mode are already implemented using the plugin infrastructure internally. So what's next on Jest, the platform? This is just the beginning of it. Runners and plugins still need time to mature and evolve. And the future applications of this are way wider. It is definitely an open area of research that I'm extremely excited about. Thanks for everything. That's it.